Let us consider application of Levi Civita symbol. Let us consider a three-dimensional space that is described by the three axes. This is the x-axis, the unit vector along which is x hat, which can also be denoted by u1 cap. This is y-axis, the unit vector being y cap, which we can denote by, say, e2 cap, and this is z-axis, unit vector along it being z cap or e3 cap. This is a rectangular coordinate system and let us write down the scalar triple product of these three unit vectors, which are the basis vectors of this rectangular coordinate system. So the scalar triple product of the basis vectors are e1 cap dot e2 cap cross e3 cap. We can also write it as and we can write e3 cap first and present it in this manner also. And the value of each one is unity, because e1 cap cross e2 cap is e3 cap and e3 cap dot e3 cap is 1. We have written down three relations, and in these three relations 1, 2, 3 occurs in a cyclic fashion and the value of it is 1. So there are three relations. Let us rewrite these relations interchanging the order of the cross products. For instance, we can write it as e1 cap dot e3 cap cross e2 cap. Let us interchange the order. Here too we interchange the order, and the value is obviously -1 because we have interchanged the order, and vector product or cross product is not commutative, it is order dependent. Changing order extracts a negative sign. Now a study of these three relations shows that the indices 1, 2 and 3 occurs anticyclically. After 1, 2 should come, but here we have 3. So for this anticyclic occurrence of the indices, the value of the scalar triple product is -1, and we have three such relations. We can also consider the scalar triple product that can be formed with the help of these basis vectors, picking up any one twice or any one thrice, as follows. Or and so on and so forth, and all these relations will give 0, and there are 21 such relations. So altogether there are 27 relations. We can club these 27 relations and write it in a single relation as where epsilon ijk represents the Levi Civita symbol, which is 1 for cyclic occurrence of indices, which is -1 for anticyclic occurrence of indices, and which is 0 if indices repeat. We next consider the vector product of the basis vectors. Consider x cap cross x cap, which is e1 cap cross e1 cap, and this is 0. Similarly, we have the other relations. So in general, we can write ei cap cross ei cap is 0, and this can be represented through Levi Civita symbol by attaching the indices I, and then it can be anything. Since indices are repeated, it is always 0, which we should get for these type of choices. So this is epsilon 3, 3k. This is epsilon 2, 2k. And this is epsilon 1, 1k. Let us now consider relations like x cap cross y cap, which is z cap. And this can be written as e1 cap cross e2 cap is equal to e3 cap. And this e3 cap can be written as Levi Civita symbol 1, 2, 3, e3 hat. And this is plus 1 as we have here. Let us consider or write down the other relations in a similar way. And this gives us 2, 3, 1. This will be y, that is e2 cap, Levi Civita 3, 1, 2, which is plus 1. We find that the indices in these relations occur cyclically 1, 2, 3, 2, 3, 1, 3, 1, 2, and therefore the general relation can be written in this way. J comes after I, epsilon I j k, so the cyclic relation is maintained. So we now write the other set of relations. Y cross x is minus z, and this can be written as e2 cross e1 cap is minus e3 cap. So this is 2, 1, 3. And Levi Civita 2, 1, 3 is minus 1 because 2 should be followed by 3 for it to be cyclic, but in this case it is followed by 1. So the arrangement is not cyclic but anticyclic, and therefore it is minus 1. Similarly, the other relations. Three, 2, 1. And then xz. X cross z is minus y. This can be written as 1, 3, 2. And 1, 3, 2 is minus 1 because of the anticyclic occurrence of 1, 3, 2. 3 comes after 1, breaking the cycle. These relations can be put in the general form. J, I, K, E, K cap. So these three relations are actually equivalent, and these 9 relations can be clubbed into a single one, which is, let us write this one. So this is how the vector product of basis vectors can be expressed using Levi Civita symbol in a very short or compact notation. As next application, let us mention that the component of a vector product say A cross B can be expressed elegantly and in short using Levi Civita symbol. Consider the ith component. This can be written as Levi Civita ijk ajbk, this being the ith component. This means a sum over repeated index. The indices that repeats are j and k. So we have to perform sum over j and sum over k, and after summation is being done, j and k will not be there in the left hand side, only I will be there. Clearly this is written using Einstein's summation convention, which is sum over repeated index. Let us check this formula and we will derive the first component of this vector product or cross product A cross B. So this is equal to, instead of I we have 1, so Levi Civita 1jk ajbk. Now we have to sum over j and k. Now there will be lot of terms, but only few will survive. We note that j cannot be 1, because if j equal to 1, then Levi Civita symbol is 0, because then the index 1 is repeated. Similar is the case for k equal to 1. If k equal to 1, then 1 index repeats and Levi Civita symbol is 0. So k cannot be 1. And this means j and k will assume values 2 and 3. And again, j cannot be equal to k, because if they are same, then again Levi Civita symbol will give 0. Clearly, these are the conditions to get the non-zero surviving terms. So the surviving terms are, let us take j equal to 2, so k cannot be 2, it is 3. So it is A2, B3 plus, now let us take j to be 3, then k cannot be 3, it is 2. So it is A3, B2. Now this is plus 1, and here because of anticyclic recurrence of the indices it is minus 1. So we have A2, B3 minus A3, B2. Now putting instead of 1 x, instead of 2 y, and instead of 3 z, we have the x component to be And let us consider determinant that represents A cross B, and it is, here we have in this row AX, AY, AZ, and the last row is BX, BY, BZ. So then the X component will be given by AY, BZ minus AZ, BY, which is what we got here starting from this formula. So this formula is established, and clearly it is a very simple formula that we'll be using over and over again. Let us now consider some examples of this formula. The angular momentum is given by vector L is r cross p, where r is the position vector and p is the linear momentum. Or also called the radius vector. So what will be Lx? Now Lx is actually L1, and therefore from this formula what we get is one jk rj pk, and this on expansion gives us this is plus 1, this is minus 1, R2 is actually Y, P3 is obviously PZ, R3 is Z, P2 is PY. So Lx is YPZ minus ZPY, and this can be checked from a determinantal expression of this cross product also, as we had shown in the previous problem. Now let us mention a few more examples. The expression of torque, which is vector n is r cross f, torque is vector n, r is radius vector or position vector as mentioned, and this is force. Then Ni can be expressed as an exercise. Let us find Nz. Now Nz is N3, and therefore instead of I we will put 3, so we have 3 jk rj fk. So let us expand and write it as 3 1 2 r1 f2, and the other combination that is possible is choosing j equal to 2 and k equal to 1. So it is 3 to 1. Now we note that this is plus 1 and this is minus 1. This is x, this is fy, this is y, and this is fx. So the result that we get is x fy minus y fx, and this is nz. As another example, let us mention the relation between linear velocity and angular velocity. Which is given by omega cross r, and let us write down, say, the alpha-th component. Previously we used the dummy index I, now let us use alpha because they do not really matter, alpha, beta, gamma. Now we'll have to write omega, and then we have to write r. So beta here and gamma there. So this is the formula, and let us try to find out V2, that is Vy. So V2 will be alpha is 2 omega beta or gamma. So we can expand it. So it will be 2, 3, 1, and the other option is 2, 1, 3. Now this is plus 1, this is minus 1, this is omega z, this is x, this is omega x, and this is z. So what we end up with is Vy equal to x omega z minus z omega x, as can be verified from the cross product of omega cross r in determinantal form. Let us give example of two more vectors. One is pointing vector, which is denoted by vector s, and its definition is E cross vector B by mu 0, where E is the electric field, B is magnetic induction, and mu 0 is the permeability of vacuum, and the alpha-th component of pointing vector s can therefore be written as mu 0 Levi Civita symbol alpha beta gamma E beta B gamma. The electromagnetic field momentum density is defined as vector PF epsilon 0 E cross B, where epsilon 0 represents permittivity of vacuum, and its alpha-th component can be expressed as E beta B gamma, and these are important expressions, the form being compact, short and elegant, and hence useful. With the help of Levi Civita symbol, determinant can be expressed and this is as follows. For instance, determinant of A written in this way, and the determinant is A11, A12, A13. This is the first row, the second row being A21, A22, A23, and the third row is A31, A32, A33. Instead of taking so much time to write this determinant, we can equivalently express it in terms of Levi Civita symbol by writing and we'll check it now. Let us make a check. So we start with determinant A and this is the Levi Civita symbol, and this is AI1, AJ2, AK3. Clearly I, J, K are the left indices, while the right indices are 1, 2 and 3. There are so many terms, but the surviving terms correspond to indices having the values 1, 2, 3, 2, 3, 1 and 3, 1, 2, which correspond to cyclic repetitions, and the acyclic or anticyclic occurrences 1, 3, 2, 2, 1, 3 and 3 after 3 1 should come, but let us break the cycle and write it 3, 2, 1. Besides these 6 terms, we have 21 more terms, all of which are 0, and together Levi Civita symbol has 27 components. So we shall now write down only the 6 components because others are 0. So we'll start with epsilon 1, 2, 3, which means I is 1, J is 2 and K is 3. And there are 3 A's. The rightmost ones are 1, 2, 3. So it is 1, 2 and 3. And the left ones are I, J, K, the values of which here are 1, 2, 3. So it is 1, 2, 3. So we have written down the first term. The second term is Levi Civita 2, 3, 1. Write down the rightmost terms 1, 2, 3 and then the left ones 2, 3, 1. Then let us write 3, 1, 2. The right ones are 1, 2, 3 and the left ones are 3, 1, 2. Then we have 1, 3, 2. One, 2, 3 are the rightmost indices and the leftmost indices are 1, 3, 2. We have 2 more terms, one corresponding to 2, 1, 3. One, 2, 3 the rightmost ones and the left ones are 2, 1 and 3. And now the last term, which is the rightmost ones are 1, 2, 3 and the left ones are 3, 2 and 1. The first 3 terms will be plus because the corresponding Levi Civita symbol stands for plus. So this is plus 1, this is plus 1 and so is this one. The remaining 3 terms correspond to anticyclic repetitions or combinations of indices and corresponds to minus 1. So this is minus 1, minus 1, minus 1. We now take A11 common, and A11 occurs in this term as well as in this term, and therefore we can write A22 into A33 minus A32 A23. Let us now focus attention to A12, which occurs here also, and therefore it can be taken common. So we are left with A23 A31 minus A21 A33, and the remaining terms are these 2 terms from which we can take A13 common, and therefore we have A21, A32 minus A31, A22. Now this can be expressed through a determinant as follows. A11, A12, A13. So we get the first row. Then we have A22, A33. So let us place A22 here, A33 there, and then A23, A32. And then we have A23, A31. A23 is already here, so A31 will be here, minus A21, A33. So A33 is here, A21 will be here, and then A13, that is to be multiplied with these cross terms rising from this multiplication, A21, A32 minus A31, A22, which means we have got back the original determinant that was written over here. So this is a very compact and short notation for determinant A.